Okay, so we're looking at booklet B today. Alright, let's start. Now, for the first question, match organ B to E, their correct functions by drawing lines. Now, I want to stress again, whenever you are looking to do this kind of question, you must use a ruler and use a pencil. Because if in exam you make a mistake, it is very difficult. It is very difficult to actually change. You have to use your correction tape. Alright, so be very careful. So this is pretty straightforward. So B is actually your stomach. Okay, it churns and break down food into liquid form. C is your large intestine. Okay, so your large intestine basically absorbs water from undigested food. Now, not just water, can you just add in and and mineral salts. Can you just add this in, please? Thank you. So it doesn't just absorb water, it also absorbs mineral salts. Okay? Now, D is actually your small intestine. Alright? So what happened here is digested food substances is absorbed into the bloodstream. Okay? E, now, is actually your rectum. Undigested food is stopped here before passing out from the body. Okay? So I'm actually going to write down the names of the various parts of your organ so that you know. So A is your gullet. B is your stomach. C is your large intestine.
No, I thought it's anus.
Nope. D is your small intestine.
I see E.
Now E is actually your rectum.
I thought it's anus.
No, anus is all the way here. Okay?
Anus! Is my anus my butt?
Alright?
Is this wrong? Is my anus my butt?
No. They are two different things.
Where's our anus?
Your anus is right at the end. Right at the
I see
end
our,
over here. Okay.
Where's your anus? My one. My mom is there. Okay.
Okay. Please write it down as a form of revision. Okay, moving on. Next. Yes, of course. You can use pen or pencil, up to you. Okay, we have to go on already. So anything that you missed, please watch the video and then copy it later on. In 3, 2, and 1. Next. Match the body parts and function to the correct body system by joining the boxes. So once again, okay, so this looks like your digestive system. This organ over here is actually your large intestines and your small intestines. The second one is actually your muscular system. And then after that, the last one is your respiratory system because it shows the lungs, okay, over here. Now, the function of your respiratory system, alright, is to actually take in oxygen into our body and remove carbon dioxide. This is also known as gaseous exchange.
Yes, sir.
Alright, while your body needs oxygen and gives out carbon dioxide. Your muscular system allows us to move different parts of our body. Okay, your skeletal system protects the internal organs. and provide support for your body. Now, it's also important to note that your skeletal system and your muscular system works hand in hand. Okay? Now, that means you think about it. When your muscle is working alone without your skeleton, your muscles will just be a block on the floor. Okay? It will be shapeless. It's just, a whole entire lump of muscles. There's no shape. So without your skeleton, you cannot move at all. But your skeleton alone also cannot move. So you need both your muscular and your skeletal muscle. So your digestive system breaks down food into simpler substance. Now, I want you all to note that the reason why it breaks down into simpler substance is so that it's small enough
To digest.
to be absorbed into the bloodstream. Write this down.
It's not chalk. It's chalk, I got correct.
Okay, that's good. Okay, so this is really to help you to make sense of what is happening and to revise.
The rest. Can use my blue pen to do the one if I didn't die. So I just retain.
Please write down all these annotations that are here to help you revise. Okay, your weighted assessment is up and coming. Moving on in
Easy.
10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, next. Ariel wanted to conduct an experiment shown below to find out how the size of biscuits would affect the rate at which they were broken down. The same amount of digestive juice were added to each setup. After an hour, she observed that biscuit in setup C were broken down the most, and the biscuit in setup A was broken down the least. Now, whenever you do this kind of question, the first thing you always do is to always identify the topic and the concept here.
Mr. Chow, how do you get off the digestive juices from your body? Oh yeah,
Aiden, if you have a question, you raise your hand. I will address your question later. I heard you. But the thing I want to say here is you must always identify your topic followed by the concept. So the word digestive here already tells you that this is actually on your digestive system. This is the topic. Now, next, they talk about the different sizes. Okay? So you can actually relate this. Ask yourself in the back of your mind, if you have watched my revision video on digestion, you will actually know that there is one part of the digestive system that actually breaks things down into smaller parts. Which part of it? That helps to break large food substances into smaller pieces. Your teeth, right? Okay. So the concept over here, if you relate it back to the teeth. So remember I told you have to memorize. The teeth breaks down breaks up large substances into smaller pieces so that it increases what? Increases surface area, very good for faster digestion. So the concept over here is talking about how the increase in surface area or exposed surface area actually increases digestion rate. So straight away, you can zoom in into this concept. Okay? Now, what was the relationship between the size of the biscuit and the rate they were broken down? Okay, you need to be very careful. So they're looking at size of biscuit. Don't tell me about, they were digested faster. I didn't mention anything they were digested faster. I used the word broken down. So follow the same. So basically they told you, right? Okay, set up C was broken up the most. So broken up the most means that it's also the smallest. So given that it is the smallest, it was also uh, faster. Okay, so you can say that the smaller the size of the biscuits, the faster the rate which they were broken down. Okay? So remember, whenever talking about a relationship, you need to describe two trends. Okay? Now, the next question states that Ariel's grandmother has problems digesting her food. So her doctor suggests she chews her food more thoroughly before swallowing. How would this help her grandmother to digest her food more easily? Okay, so in fact, this question, right, there's a wrong keyword here. You cannot say more easily, you have to say faster. Because easily is very general. I do not want to see that in your answers. Please be very careful. A lot of you make that mistake. So once again, when you chew more, relate it back to the function of the teeth. I told you already, you have to memorize. Whenever you talk about chewing food more, okay, you have to talk about how the food breaks up into smaller pieces, therefore increasing the surface area exposed to digestive juice. Hence, your digestive juice rate of digestion will increase because of that. Okay? Okay, so chewing her food more thoroughly helps to break up the food into smaller pieces. Now you have to tell me that this is a smaller pieces, okay? This increases the surface area of the food exposed to digestive juices, hence increasing the rate of digestion. So what happens here is we're using a new strategy known as cause and effect. So as you can see at the beginning, because the food became smaller, okay, so we say that this is the cost, C-A-U-S-E. The effect of it is that it will increase the surface area of the food exposed to the digestive juice. So this is a very good way to actually answer your questions. A very good strategy. Okay? Finish copying first. I never move. Kai An.
Now we social studies already.
No, not yet.
What time is social studies?
12:15.
Can we put the 11:46? Can we put the
No. You still have water.
I'm gonna finish soon.
All right. Okay, the next question. The diagram below shows the human digestive system. Label the part where physical grinding of food is taking place with the letter X. Now, grinding means the breaking down, okay? Okay, no, actually they are referring to the mouth. However, a lot of you got it wrong because you don't know how to label. Let me explain to you. Some of you label with an arrowhead. Some of you do this kind of thing. You put X here, and then after that, you put here. How come there's a gap? Are you labeling the space? Some of you put here. You're labeling the nose. Some of you put, I don't know, you put here. Okay, so the proper way of doing any labeling, proper way is to actually use a pencil and a ruler. Okay, please, I did say 10 billion times already. Draw a line to where you want to actually label. Okay, let me just redo this because I want to show you properly. The line has to be straight. It should end at where you want to point at. And then what you do is you put an X like this. Okay, I say again. Okay, some important points to note is that, okay, the labeling line must touch the structure. Okay, it cannot be floating in the mid-air. This is the best way to label something. So a lot of you never do it properly, then that's why you all didn't get the marks. As long as I see a gap there, I cannot award you the mark. Okay? Give you another 5 seconds before I move on. Okay, moving on. Okay, two identical plastic bags, A and B, were filled with 100 cm cube of sand and 100 cm cube of air, respectively. Now, the word respectively means in order, actually. Okay, so that means the 100 cm cube of air here refers to the first one. Okay, so the 100 cm cube of sand, refers to bag A because bag A was mentioned first. And then after that, the 100 cm cube of air refers to bag B because bag B was mentioned secondly. So this is the meaning of respectively. Okay? So when Sally added more sand into plastic bag A, the sand overflowed. When she added more air into plastic B, the air could go in. Based on the above experiment, what can Sally conclude about the difference between property of air and sand? So in this case, okay, you need to identify the topic again. So the topic in this case is actually what? Matter, very good. And the concept they are testing you is actually properties of solid versus air, gas. Okay, that is the property that they want to test you on. So wherever you answer this kind of question and you are not so sure, I always suggest to you to construct yourself a table. Okay, what do I mean by that? Yeah, a table of the different properties. So you remember that in my table that I always show you, okay, I'm going to show you again because some of you might have forgotten how to construct. Oh, sorry. Okay, so what happens is you have definite shape and definite volume. And then after that, you have the three different states. So what are the three different states? The first one is what? Solid, liquid, and gas. So you would know that the solid has a definite shape and a definite volume. A liquid has no definite shape but a definite volume. And a gas has no definite shape and no definite volume. So because the gas has no definite volume, we say that it can be compressed. Okay? That means it can be squashed, okay, and made smaller. The amount of space. Alright, so this is what you could do in exams, which I highly recommend. Okay? So based on the experiment, what can you conclude? So we know that you cannot add any more sand into A. Alright, this tells me that which property? Definite volume. It's talking about definite volume here. So we can say that sand cannot be compressed but air can be compressed, or sand has a definite volume or air has no definite volume. Okay?
Is it sand is a solid?
Sand is a solid.
But why is it? Lost my brother says sand is a volume. But actually when he's B6, he doesn't know sand is actually a solid.
Yes, Chanel? Can. Okay, so if you say something like sand cannot be compressed but air can be compressed, you are also correct. But I prefer to use definite because I want you all to learn how to spell the word definite and be more comfortable. Okay? So then in the next question, they said that Sally then filled up plastic bag C with water. She observed that water overflowed sometime. Explain why. Very simple. Because your water has a definite volume according to your chart. Okay? If you see here, it has a definite volume. You will know that it cannot be compressed. So because of that, it will eventually overflow. So you have to say water has a definite volume. Okay, very simple. Okay, moving on in 20 seconds. Kai-an, face the front. Have you finished? In 5, 4, 3, 2, and 1. Okay, next one. Okay, this is very important. Siti used a setup below to find the volume of a ping pong ball. Siti could not find the volume with the above setup and explain why. Now, this question is actually testing you on how to find the concept. Is actually testing you on how to find the volume of small objects. So in order to use this method, right, you firstly, the item that you want to find must have a definite volume. Number 2, the object you want to find, okay, must be basically heavier than the liquid you want to put it in. So it must submerge. So in this sense, right, what happens is, normally if you put in a stone, say if this is a stone, not a ping pong ball, a stone, what will happen is the stone should sink in, and then the water level at first, which was here, just before it flowed out, it will increase. And any excess water, because of the volume of this stone, will then flow out into your measuring cylinder. So your measuring cylinder, right, the amount of water flowed out is equal to the volume of the stone. Okay? That is how it usually works. However, as you can see in this case, it will not work because the ping pong ball is floating above. Yes, it's too light, it will float above the water. Alright? So that's why, okay, you have an issue over here and you will not be able to find. Okay? So why could not find? The ping pong ball floats. Floats on the water. Hence, water is not displaced. Now this word displaced is very important. Okay, it means to be pushed up or to be replaced while pushing something out. Okay? Alright, but when you replace something, it's not so simple as just replacing. The item get pushed away. You take the person's place. Okay, that is the meaning of displace. So in this case, if you push the ping pong ball down into the water by force, what will happen is that the water will actually be displaced out because your ping pong ball needs to occupy space. Okay, so when you push it down by force, the water level will increase and it will flow out. Okay, however, in this case, it cannot happen because the ping pong ball is floating. Alright? Okay, moving on in 5. Okay, moving on.
Oh my god.
Hurry up. Okay. Next question. This question you all need to be very careful. Okay? Let me explain to you why. Now, Gopa placed a glass bottle with a balloon in the basin of hot water and wrote down his observation. Okay? Describe what Gopa observed about the balloon if the glass bottle was placed in the bottle of hot water. Now, so basically, the topic in this case, if you take a look at it, is actually on heat and temperature. Now, the concept tested over here would actually be expansion and contraction. Now, how do I know it's expansion and contraction? Because can you see the balloon over here became bigger? So this will give me a very good hint that it's actually on expansion. Janelle and Gwyneth, focus. Now, so basically what will happen is, the word here is observe. So when they ask you observe, you do not need to go and explain to me why. Okay? So what you will observe is that the balloon will become inflated. Okay? To inflate a balloon means that it actually gets blown up. Okay? So it's very simple. The balloon becomes inflated. Okay, that's all. You do not need to give any form of explanation. Yes, then they ask you to explain. Now, the part that most students make a mistake is that they straight away say something like, oh, the bottle gained heat and expanded. But it is not the bottle that expanded that
It's the
caused.
balloon. The balloon expanded.
Yes, but also no. Now, you first need to identify whenever doing heat, which is the hotter region.
The hot water.
Yes, so the part here is that your hot water is the hotter region. So I use a very big arrow. And then what happens that cause your balloon to fill up, to become bigger, is actually your air. Correct or not? So your air has to expand. So your air is actually the lower temperature, but heat is being transferred this way. Now I know that you say that, oh, but Mr. Chong, the bottle is the one that is in direct contact with the hot water. Yes, I agree with you. So the most correct one should be, okay, the glass bottle gain heat from the hot water, and then heat is transferred to the air in the bottle. However, it's too long-winded for just 2 marks question. So what you could do is, you just straight away say that heat is transferred, okay, or heat is lost from the hot water to the air in the bottle, causing it to expand. Okay? So what I'm looking for is, okay, the air in the bottle remember, I always tell you, bracket lower temperature. The two region gains heat from the hot water, bracket, which is the higher temperature, okay, causing the air to expand and inflate the balloon. Okay?
Is this only one mark? Or you could...
Yeah, so you see, you say the air inside of the glass bottle expanded because of the heat from the hot water. But you never say the heat was transferred or was gained or lost? What do you mean by because of the heat? So was it a heat loss or heat gain? Right? You don't know what. Right now, you think about it. You cannot say, oh, because of food, the person got fatter. So because of too much food or too little food, that's why the person got fatter. Think about it. Okay? What? Huh? What is wrong? Oh, okay. From. Okay, my apologies. Okay, what would happen if the hot water in the basin was replaced with ice water? Now, a lot of you actually said things like, oh, the balloon will not even inflate. No, they're asking you, now it's hot water. Okay, so you remove the hot water, the balloon is still inflated, then you pour in cold water. So what will happen is that, okay, it's a 2 marks question. So you cannot just say things like, oh, the balloon will deflate. You must tell me why. Yes, so sometimes use a little bit of, common sense. Look at the marks. So the marks, okay, will tell you how much you must write. So in this case, you must say that the balloon, what? Becomes deflated. Okay, or the balloon deflates. So to deflate means that it becomes, all the air gone out or becomes smaller. Okay, so yes, opposite of inflated. The balloon deflated because the air in the bottle. Now this time round, is air in the bottle lower or higher temperature?
Higher.
Good, higher temperature. Lost heat to the where? Cold water. Lower temperature. And contracted. So because your air lost heat to your air is now hotter, okay? It lost heat to the cooler region, which is actually your cold water. It actually would contract. Okay? Go. Lin filled 2 similar containers and a plastic container and a metal container with the same amount of cold water at 3 degrees, okay, at the same time. Both containers were left in the kitchen, okay, at a room temperature of 34. The temperatures of the water in both containers were measured every 5 minutes. The table shows the changes in the temperature of water containers A and B over a period of 20 minutes. Okay? So the first thing first, you must always recognize what topic are they testing you. So you see words like degrees Celsius. So straight away you will know that the topic is actually on heat. Now what is the concept then? The concept over here is the keywords will include plastic and metal made of different materials. So the concept that they are testing you would be on good and poor conductors of heat. Okay? Good and poor conductors of heat. If anyone who don't copy whatever I copied, right? Very simple. You just stay back during recess after this and you continue.
Which one is it? I don't know what's the answer.
Page 5.
Yeah, in page 5.
Now, both containers, okay, which containers A or B is made up of metal? Now, your answer in this case, alright, you need to think back. Since they're going to test you on good and poor conductors of heat, you need to think. Remember that the key idea for a good conductor is that it allows heat to pass through quickly. So as you can see, right, container A Alright? The temperature has been higher than container B. So this means that heat from the surrounding outside is going into A at a higher rate as compared to B. Why is it going out from outside to inside? Because they tell you that temperature outside is 34 degrees Celsius, whereas the water is only 3 degrees Celsius. This tells you that heat will travel from surrounding to the water. Reason being, heat always travels from a region of higher temperature to a region of lower temperature. So which container A or B is made of metal? Okay, it will be container A. Then you need to justify. So to do that, right, whenever you're given data, you must quote evidence. Okay, you must quote evidence. Alright, and then you relate the evidence back to your answer. So you can say that in the evidence here, like I told you, okay, the water in container A gains heat faster. So you say that, okay, the water in container A gained heat faster than B. So what does this shows? Okay, this shows that just like metal, container A was able to allow heat to travel through
Can you just stop onto that metal, that's all?
cannot quickly, as metal is a good conductor of heat. Is a better conductor of heat.
I wish our research is better. Just started at 7 o'clock.
Okay, now you need to be careful that you use words like faster and better. Why? Because in this case there is only two. There is only two materials that you're comparing. So instead of saying just say good or poor, which is very general, you use the word better, faster, because you're comparing between two materials. Alright? It's okay. I'm going to just leave it there. Now, for the next question, Lynn wanted to bring some cold orange juice for a picnic. She wanted to keep the orange juice cold for a longer period of time. Which container, plastic or metal, should Lynn choose to store the orange juice? Explain your answer. So once again, you need to remember, a good conductor will allow heat to pass through quickly, whereas a poor conductor of heat does not allow heat to pass through quickly. That means it's very slow. So if you want to keep, yes, if you want to keep your drink cold, your material should be made up of a poor conductor of heat. Why? So you imagine this is actually your container. Okay, you have a poor conductor of heat as material, such as plastic. What happens is that your drink, which is very cold, nice and cold, okay, so let's just say your drink is at 3 degrees Celsius and the outside surrounding temperature is at 40 degrees Celsius. Now, heat will actually travel from the surrounding into your drink. However, because it is made up of a poor conductor, which means that, okay, it does not allow heat to pass through quickly. So your heat cannot go from your surrounding into your cold water very quickly, thus keeping your liquid colder or cold for a longer period of time. So your answer should be plastic.
How about metal?
And then you explain.
What about you use
So you say that plastic is a poorer conductor of heat.
Mr. Chong.
Hold on, please. As compared to metal. Hence, using a container, using a plastic container would prevent heat from traveling from the surrounding, which is actually high temperature, to the liquid at a fast speed or fast rate.
The light works. At a fast rate?
Yes, correct. So what happens over here is, okay, because like I say again, I'm going to explain one more time. Plastic is a poorer conductor of heat as compared to metal. So by using it, right, it will prevent heat from traveling from the surrounding, which is of a higher temperature as compared to the liquid, okay, in your container at a fast rate. So therefore, it will keep the orange juice cooler for a longer period of time.
Mr. Chong.
Okay, for this question, once again, I want to keep reminding you, because a lot of you don't practice this good habit, is to identify the topic and then the concept. Alright, it's really important that you do that in exams. Ari carried an experiment to find out how well different materials could conduct heat. Okay. There were 3 rods of different materials, PQR, and 3 identical balls of butters were placed on top of each rod as shown in the diagram. Okay. So he recorded the time taken for the ball of butter to melt completely for each of the rods below. What had caused the butter to melt? Explain how. So the first thing you will notice here is you will probably already guess that or know that the topic here is talking about heat. Now, it's very important to identify the concept that is tested, because there is so many concepts in heat topic. For example, there's expansion and contraction. There is transfer of heat. There is also about poor and good conductors of heat. So what are they actually testing you on here? Now they're actually testing you on transfer of heat as well as good and poor conductors of heat. How come I know? How do I know that? The part about different materials hints me that this has got to do with conductors of heat. Okay, and then also the fact that we're talking about the conduction of heat tells me that it's also heat transfer. Okay, so they're testing me on these 2 concepts. So by identifying what are they testing me, right, straight away I must recall what is the key idea behind these 2 concepts. So remember, number 1, the first one, transfer of heat. Heat always moves from a region of higher temperature to a region of lower temperature. So that means somewhere in my answer, I must write that down, okay, somewhere, because that is a key idea of that concept. And then for conductors of heat, straight away, remember I was telling you that when they talk about conductors of heat, when you compare conductors of heat, use the correct term. Is it poorest or is it poorer? Can you just say poor? Is it enough to just say poor when you are comparing 3 different materials? Cannot, right? Because there is always the poorest one or the best conductor. And then whenever you talk about conductors of heat, it is always about how fast, how quickly, never how easily heat can flow through. Yet, how are you listening? Okay? Now, this is very important. So once you identify your concept, you already know what you need to write for your answers, and then you can formulate your answer. So what caused the butter to melt? So in this case, remember the first thing to do is always identify, okay, when they talk about transfer of heat, you always identify the different regions of heat. Correct or not? The different temperature of different regions of heat. So the one with the highest temperature is actually here. So I'm going to draw the biggest arrow here. And then after that, it will move on to here, and then finally here. Because the butter is the furthest from the heat source in a way. It's not really a heat source because it doesn't give off heat, but it's the highest region. So heat will always travel from a region of higher temperature to a region of lower temperature, and then from a region of higher temperature to another region of lower temperature. So remember, higher, lower is always comparative. So like for example, when I'm looking at rod P, between water and rod P, water has the higher temperature. So heat will travel, okay, from water to your rod P. But then when I compare rod P and the butter, rod P has a higher temperature because it has gained heat from the water, and then heat will be lost to the butter. So once again, remember, whenever you're talking about heat transfer, you always use the term heat loss and heat gain. So if you have watched my revision video, you would have known that the strategy of this is actually HDO. Heat stands for, okay, you need to mention about heat gain or heat loss. D refers to direction of heat, and then O stands for outcome. Okay, so what are we looking at? How would the answer be formulated like? Okay, so you can say that the rods, which is actually lower temperature, okay, would gain heat so bracket higher temperature. Okay, then okay, so basically, can you see that I'm going to color code for you? The first part talks about heat gain or heat loss. There's your H, and then your direction is over here, from where to where. This is your D, and then your outcome would be melted. Alright, so this strategy will cover it. So if you have actually looked through my tutorial, you will actually understand that, hey, whatever I'm teaching you can be applied. This is another question, but yet I'm applying the same strategy. So the best way to actually get this right is to practice. practice, practice, practice. Practice does not make perfect. Practice makes habitual, meaning that you get experience. So you're more experienced at handling this kind of question. Straight away, you'll be able to identify what is the concept that they're testing you on. How is it that from the question, I'm able to pick up the keywords that will tell me what is the key idea that I'm being tested on. Yan Hao, sit up straight. Which material, P, Q, or R, was the best conductor of heat? Straight away, you see, even the question itself is actually very direct. It tells you that I'm going to test you on the concept of conductor. What should come to your mind straight away is the key idea is about heat being able to be transferred through the material very quickly for a good conductor and very slowly for a poor conductor. So that needs to straight away come into your mind. Okay, when you formulate your answer, you know I must talk about rate of heat transfer. Yes, Sam?
I don't think the water is C. I think it's water at 90 degrees Celsius.
I don't quite get your question. One more time.
No, you said at the A, you said that from the hot water C.
No, that's not C. That's bracket.
What's the bracket?
Yeah, that's a bracket. I didn't have space. Okay, so question B. So straight away, once again, they asked you which material PQR was the best conductor. Now this question is a bit of a CER also, if you realize, because once again, they are asking you to make a claim. They are also giving you data. Okay, so you can use CER to answer this. All right. Now, so in this case, if you look at it, the answer should be Q, because the time that it took for the butter to melt completely is only 2 minutes. So in this case, it's one of those questions that the answer is inverted one. Usually, the bigger the number means better, right? For example, someone who has $10,000 is richer than someone that only has $1,000. So the bigger the better. But in this case, it's the smaller the number, the better. Okay? So in this case, Q took the shortest amount of time. So what you need to do is, first you need to state, okay, Q. Now remember, stating Q alone does not give you any marks. I stress again, 0 marks. You don't get the marks. Reason being that it could be a lucky guess. So the examiner will not award you any mark because there's only 3. So you anyhow throw one inside will also not get you the mark. It's the behind part where you justify, okay, they look at your justification, does it make sense? So the next part of it, you're going to talk about your evidence. So from here you say that, okay, the butter, okay, on material Q, on Q took the shortest time to melt. Now once again, you need to take note, shortest, not shorter, not short. Because there are 3 different materials, you need to be very careful with the form of comparison word that you're using now. Okay? Compared to materials P and R. So this is like your evidence. Okay? Now you have to give your explanation as to why. Now in this case, it's not really CER because in a way, okay, I mean it's CER, but the R is not really for a purpose or for a user. It's not like you choose a material, then you say, oh, you know, so when you make a chair out of it and the person sits on it, it doesn't break easily. In this case, the reason is more like explanation, asking you to explain. So remember, when you're looking at conductor, I told you many times already, there's a key idea. The idea is always rate. Rate of what? Rate of heat transfer, which a lot of you didn't talk about. Okay, so you have to say that, okay, material Q was the best conductor of heat? As it gained heat the fastest. From the hot water. So this is actually your reason or your explanation. So this one, right, is prior knowledge. Okay, because you know that a good conductor of heat will allow heat to travel very quickly. Okay, so I'm going to color code it once again so that it's more succinct for you. Okay, so this part over here is, oops, sorry. Give me a minute, let me undo this. This is your evidence. This is your reason. And then this is your claim. Now, be very careful. I want to stress once again that you have to use words like best conductor of heat. You cannot say good conductor of heat. Okay, because you don't know what is material XYZ. Oh, sorry. PQR. You don't know what are they. Okay, but yeah, exactly. Plastic is actually a poor, they could be all plastics. They could be all plastics, but different types of plastics. So plastic on its own is actually a poor conductor of heat, supposedly. Okay, so but in this experiment you don't know. So instead of saying good or bad, you have to use the word best conductor in comparison to the rest. Alright, so you really need to be very careful when it comes to experimental questions like these. Okay? Alright, moving on to the next question. Any questions so far? Am I clear? Okay. So this is very straightforward. If you don't know, okay, you need to revise again. So this is the flower. Sorry, am I missing a question? What happened? Oh, B is too small. Is this better for you? Okay, if not, copy for someone. I cannot be hanging here for you. Okay, next. Flower is the first one. Okay, this is your stem. This is your fruit. And this is your root. Okay. So obviously, I hope everybody knows that Y is actually your leaf. Okay. Now be very careful of your spelling. Leaves versus leaves. Leaves is the plural form of leaf. Okay. Leaf is to mean that you're going somewhere. Okay. So what is the function of Y? So function of Y is actually to make food for the plant. Okay, but it'd be very good if you can include sunlight or you can use the word photosynthesis. Okay, so you can say that the function of Y is to trap sunlight for photosynthesis. If in the exams you cannot spell photosynthesis, you may use make food for the plant. However, I stress again, this term photosynthesis is required when you reach upper level. I suggest you learn it now. Okay? Next, Afika conducted an experiment with the setup as shown below. 3 days later, she noticed that there was a change in water level and the color of the leaves as shown. Okay, why was there a layer of oil used in this experiment? Okay, now, most of you got the first part correct, but the second part of the answer, a lot of you left it out. A lot of you said that the layer of oil was to prevent the water from evaporating. My question to you is then, why do you want to prevent the water from evaporating? Right? If you just put there to prevent the water from evaporating, so why? Why do you want to do that? Okay? You're missing a key concept, Owen. Okay, figure it out. Now, what you are missing is that you need to tell me, okay, why do you want the water not to evaporate? This is so that the water, any water loss, is due to the water that is being absorbed by the plants. Okay? Alright, so for example, let me put it down for you. Okay, so the answer is actually two parts. The first part is to prevent the water loss from evaporation. Okay. Now, why you want to do that is to ensure that the decrease in water level is due to the absorption of the roots and nothing else. Okay, because this is part of the experiment. You want to see what happens to the water level. So, by knowing the aim of the experiment, by understanding the aim of the experiment, you would be able to understand, okay, what needs to go into your answer. Because the aim of the experiment is for the water to go up to the leaves, okay, via the absorption of your roots. So if let's just say the water gets evaporated, you don't know whether or not the leaves turn red. Is it because of some pigments from the surrounding air? You know what I'm saying? Or where did they get? But if let's just say you know for sure that you have covered the water with a layer of oil, okay, definitely the only way for the red colored water to travel to the leaf will be via the absorption of the roots and nowhere else. Okay? Yes, Yan Hao, you have a burning question?
What happened to the oil after?
Nothing will happen to the oil.
They just stay here.
It will just remain there. Okay? Moving on in.
What happens if the plant absorbs the oil?
Okay, the plants most probably would not be able to absorb the oil because the oil is very thick. Yes. Okay. Yes, Braden. Okay, whoever it is, please sort your matters out. Okay, moving on. Study the diagram below carefully. Okay, what do the arrows above represent? This is a very simple question, but at the same time, many people got this wrong. So I need you to focus on the screen, eyes on screen. So if you take a look at it, the arrows are coming from this area here. This is actually the soil. So you need to understand what is in the soil.
So in the soil, you should know that there is actually two things: water and dissolved mineral salts. Alright? So these are the two things that comes from the soil. So not only that, remember I told you when it comes to science, okay, arrows with an arrowhead depicts direction or movement. I told you all this many times. That is why you cannot use arrowheads for labeling. I said at labeling you must always use, can you see, this is a very good example. They just use one straight line like this, no arrowhead. So arrowhead depicts movement or direction. So therefore it actually shows you the movement of water and dissolved mineral salts from where? From the soil to actually the plant. Okay? So basically the arrows represent of water and dissolved mineral salts. Okay? So if you're even better, you can tell me shows the movement or shows the flow of water and dissolved mineral salts from the soil to the plant. Okay? But you do not need to do that because generally it's just the general flow of it. Okay, moving on in 5. Joe, are you writing down? You do know that if let's just say when I check your work, okay, it's not done properly, we're going to have to do it again. Please, mindset of excellence. Right, moving on in 5, 4, 3, 2, and 1. Next, plant P was placed in a beaker of red colored water for 2 days as shown. After 2 days, the leaves were stained red. Okay, the stem was cut at point A, and cross section of stem is shown below. So I'm just going to do a very quick revision with you. So actually one look at it, you know that this is actually to do with your plant parts, okay, or plant transport system. Okay, so in this case, you have your food carrying and your water carrying tube. The one that is outside is your food carrying tube. And the one that is on the inside is your water carrying tube. Okay. So explain why the leaves were stained red. Alright, so you need to tell me that which tube actually carried the water, alright, from where to where. Some of you said the stem. That's also fine in accordance to the question. Now I know that a lot of you have not actually learned about the exact structure of water carrying and food carrying, haven't teach you yet, but you can use the word stem. So in this case, what I should see is the stem. I must see. You cannot just say water transported or water went to the leaves. It's too general. You have to tell me the stem transported the red colored water from the beaker to the leaves. Okay, so it is very important to tell me whenever the function is a transport function, you must always tell me from where to where. Don't just tell me, oh, stem transported red color water to the leaves. Where did the red color water come from? Because whenever you transport something, it is always, you must think of it as in like it's from point A to point B. So you must tell me where's your point A. A lot of you don't tell me where's your point A. You just go to point B straight away. Okay? I've said this many times. I'm saying it again. State another function of the stem that is not shown in this experiment. Alright? So a lot of you couldn't get this question correct also. So you must look at this experiment. What is it not testing for? So you realize that one of the function of the stem, if you remember, is to hold the leaves upright or hold the whole plant upright so that the plant gets maximum amount of sunlight. Okay? So that is one of the things. So the stems holds the leaf upright. Can also. You can say support the plant, hold the plant upright. Okay? It's all about the same idea. The whole idea is we want you to understand that the stem doesn't just transport things. It also enables the leaves to actually get the maximum amount of sunlight. Now I know that this is a very difficult abstract idea. However, let me give you something a little easier to imagine. Now, if you were to walk into a rainforest, you realize that all the trees are very, very tall, right? But what makes the tree so tall? It is actually the what of the tree? The trunk of the tree, which is actually the stem, right? So the stem is supporting the tree all the way up and enabling it to get the maximum amount of sunlight. All right? So in smaller plants, that's a bit more difficult to understand because they're not competing. But in the rainforest, it's very important to be the tallest, to be the highest. Okay? From the experiment conducted above, what characteristics of a living thing does the plant show? Now this question is a very, very, very easy, but at the same time, a lot of you don't bother to put in enough effort to think about what the question is trying to ask you. Now they are talking about what characteristic of a living thing does the plant show. Most of you tell me plant needs air, food and water. And living things needs air, food and water to survive. Excuse me, are you sure that this experiment shows that it needs air? Did you remove the air and then did you remove the air in one experiment and repeat it with another experiment with air to show that the plant needs air? You didn't. So how can you say that, oh, this experiment shows that the plant needs air or living thing needs air to survive? It doesn't show that. Neither does it show that it needs food. Does it? So are you feeding the plant anything? Are you removing sunlight? No. The only thing that was mentioned here is which one? Out of air, food and water. Which one? Air, food and water. Oh yes, only water. So you can only say that, okay, a living thing needs water to survive. Okay, a lot of you tell me air, food and water, which is wrong. The experiment doesn't show anything to do with air or food, only water. Go and think about what I say and then look at your own answer. Was it a question whereby you didn't put enough thought into it and you just generalize it and then just write in a very general answer? Okay, think. Alright, and the only way that you can get better at this kind of question is to actually practice to gain experience. Next. Okay, question 40. Okay, Now, materials question. Straight away, I look at it, I know it's a material question. Why? Based on experience already. So remember, I know I'm very naggy. Identify the topic. Identify what concept are they trying to test you on. So in this case, straight away, the topic is on materials. And I already know that it's testing me on properties of strength. Correct? That's what they're testing me, property of strength for materials. So in strength, okay, we know that it does not break easily. Can hold the most amount of weight without breaking. Okay, the stronger the material, the more weight it can hold without breaking. Alright? So Florence carried an experiment as shown, okay, in the diagram below. Material A was placed over 2 blocks. Okay, bricks were stacked on top of material A until it broke. Okay, so you keep stacking, stack until it breaks. She repeated experiment using 3 other materials, okay, A, B, C, D, of the same thickness. Okay, the bar graph shows the number of bricks needed before materials A, B, C, and D broke. Okay, so very straightforward, right? Remember, once you identify the concept already, I know already, they're testing on strength. They're probably going to ask me what which is the strongest later on. Okay, so what is the aim of the experiment? I think this is very straightforward. Okay, the aim of the experiment is to find out which material A, B, C, D is the strongest, or what is the strength of the 4 materials. Okay, very straightforward question. Based on the graph above, which material A, B, C, D is the weakest? They did not ask you to explain. So in this case, the answer will be B. Why? Very straightforward. It broke at 2. When it comes to graph reading, right? Attention, students, is very important. Please use a ruler, and then after that, okay, draw it across so that you can read the numbers accurately. Okay, it is very important that you're able to draw a straight line to help you read. If the exam question doesn't have guidelines or grid lines to help you. Based on the experiment above, which material A, B, C, D would you use to make a chair? Explain your answer. Which answering strategy would you use? Louder. CER. Okay, it's very straightforward. So the answer is actually, if you look at it, for my C, the answer is D. Yes, answer should be D. Okay, material D, that's my claim. Okay, material D. Then the next thing about it is, okay, why? So if you take a look at it, it actually required the most number of bricks before it broke. You have to quote it exactly. You cannot just say it is the strongest. Yeah, but it says evidence. That's not evidence, what? It's just that I say Natasha is the strongest amongst Javier and Jaden. Then you all look at me and say, how can it be the case? Mr. Chung, where is your evidence? Exactly. So you cannot just say, oh, because it is the strongest. No, you have to tell me what is the evidence. Okay? So your evidence would be something like, okay, as it can hold or withstand. Okay, I like to use this word withstand, but hold is fine. Hold the most number of bricks before it breaks. Well, tongue twister. Making it the strongest material compared to A, B, and C. Okay? So I should not just leave it there and say, oh, it can withstand the greatest number of breaks before breaking. What does it mean? It means it's the strongest. This is just like your light intensity question also. Okay, so you say that the light detector did not detect any light passing through material X. What does it mean? It means that material X is actually opaque. Very good. Don't leave it hanging there. What does it mean? What does it suggest? Okay. Then after that, the last part, your reasoning. Okay, your reasoning. Why do you want to use this material? How does it benefit the user? Okay. So, by using D to make the chair, it will not break easily. When someone sits on it. I know it's very long-winded and you all are very doubtful. Okay, wow, Mr. Chong need to write so much. Are you sure or not? Are you trying to make me copy more than what is needed? Come on, every time you all write short form, you all don't get the answer, right? You all don't. And I can show you that the answer key is really this long. It is really this long, literally. So it's either you listen to me, follow what I say, write the required amount and get your marks, or you can try doing it your own way and still not getting the full marks. Okay? Alright, hang in there. Last question already. Okay, moving on in 5, 4, 3, 2, 1. Okay, for those who needs a little bit more time, please refer from your friends. We really need to move on. Okay, these questions. Once again, topic magnet. Okay, straight away, why is it magnet? Oh, the question is already showing you a magnet diagram. The next thing is, when you look at it, it is actually looking at the strongest, which one has the strongest magnetic strength. So once again, when you think about magnetic strength, what comes to your mind, the idea? Opposite poles attract. Okay, that's one. The next thing is, okay, the nearer, okay, something that's a very strong magnetic strength, right? Okay, doesn't need to be that close to the object in order to attract it. So the stronger your magnetic strength is, the further away the magnetic object needs to be, okay, in order to be attracted by this magnet. Alright? Okay? You think of it in this way. When you look at a very cute corgi puppy, oh, so adorable and everything else, from far away, this cute puppy, okay, you'll be attracted to it already, right? Versus something that is not so, like a spider. Yeah, you're not very attracted to a spider, even, yeah, in fact, you want to run far away from it, okay? So, they tell you that she adds weight to the string attached to the magnetic material, okay? Until the magnetic material was separated from the magnet. Okay, so what happens here is that you have a weight over here and you keep adding it. So when you add weight, you will actually pull the magnetic material in this direction. Okay, the more weights you have, the greater the pull. So obviously, if your magnet is very strong, you'll be able to attract this magnetic material, okay, very strongly. So you require more number of weights. The more number of weights you require to separate, the stronger the magnet is. Okay, so the question asks, which magnet has the strongest magnetic strength? Very straightforward. Your answer should be C, because it requires the most number of weights to be added here, over in this area here, okay, in order to pull, to separate the magnetic material away from your magnet. Okay, so what could your answer be like? So your answer should be telling me the claim, right? So magnet C, okay, Y. It needed evidence, correct? The most number of weights added before it was separated from the magnetic object or magnetic material. Compared to A, B, and D. Okay, so make sure you quote evidence. What should Aretha do to ensure her results were reliable? Now, reliability has got to do with how many times can you repeat the experiment and get the same answer. So the whole thing is, when you talk about reliability, means how often can the results be same. It's not about being fair, it's about being the same. Be very careful. So for example, if let's just say I take for example a student, John. John always comes late to school. So we can say that he is very reliable in coming late to school. Yeah, exactly. That is what it means, you know. So in experiments, you always want your experiment to be reliable, okay, by saying that it can be repeated and the answer will always be the same. So what you can do is to repeat the experiment a few times. So a few times means 3 and above, and find out the average number of weights needed to separate the magnetic material from each magnet. Okay, so you should repeat and then you find the average. Why average? Because sometimes maybe due to human error, maybe due to the wind, okay, or for whatever factors, there could be a slight error. So the more times you repeat and then you have a bigger number to average it, the more accurate your answer would be. Okay, so even things like, for example, they say things like, oh, the average height of a child at 12 years old should be this height. So what they do is they measure all the children at 12 years old in the whole country and they divide by the number. So the bigger the number, the more accurate, because you're taking in more samples. Okay, less room for error, making your results more reliable, being able to be repeated every single time. Okay, so you think of it as if you do 10 times, out of 10 times, actually got 1 time you make error. Okay, at least when you average your data, it won't be so bad. Okay, the more times you do, the less error will be, more reliable.